Good day and welcome back to Object-Oriented Programming, OOPS with Python, Code Reusability and Optimization. So now we are, now to the most important part of Python programming, which is Object-Oriented Approach. So we shall be learning Object-Oriented Approach now. And before we get started, let me give you the recap of what we had learned in the previous class. We started with class computer. Right, and we started with classes, and said classes can have attributes, and classes can have, those attributes can be variables, and the behavior can be methods, right? For example, name, bark. I told you that, I gave you that example in the previous class as well, right? So the class has attributes, you may call them as variables, and the behavior of the class is known as by methods. Now what is the difference between function and method? Well, whatever is, for example, if I make this here, so it is defined display, so this is called as a function, right? So I'll say print hello, it's just a function, right? So now if I take this function inside a class, right, now let's say computer, right, saying it's inside a class computer, so I'll have to indent it accordingly so that it goes inside the class. Alright, so now this function is not a function now, so now this is the method. Now if you call this, you will say C is equal to computer, and then you will say C dot display. So now any function that is called with the object name, right, with an object, C is an object, then you use the object to call display, right, is a method. So now inside classes, when you call them, outside the classes, when we call them with object names, we are calling the method of classes. Now display is method of computer class. If you take class away, display instead of method becomes a function. That's why I have written here, function is a function without a class, but inside classes it is method. So function can be function outside the class, right? But inside classes it's always a method. So we'll be using method henceforth to define a function inside a class. We'll be using the keyword, we'll call that method. Now let's get quickly started, and let me just show you a few more things, right, regarding this. Okay, now whatever we say that whenever we say we can say like we make a class. So whenever we make this class, let's say any class, it doesn't matter, computer is not a hard-coded rule that you should apply, right? So as I said, if I make a call to this class, let's say C1 is equal to computer, so this is going to generate an error, right? Expected and indented block. That there's nothing inside the class computer. Now class computer needs to have a body. You have not defined the body of class computer. It's an empty class. You'll say, hey, just I'm using it for testing purposes. Pass will not check. It means it's okay. You don't check for indentation here or any other thing. So now we're able to call this, right? So now what is this? I told you whenever we have this is basically a call to the function or the method parameter attributes, right, or method parenthesis, right? I told you when we started, but you'll say, sir, we don't have any method in the class, right? What are we doing here? Why are we mentioning those parentheses with computer? Computer is a class, it's not a function. As I said in the previous class, that this is basically a call to a basic constructor, which is always there. Right, even if I don't make it, it's already there, right? So even if I don't make it explicitly, right? So now, yeah, in case if I make it, for example, how do you make it? So I'll say define. So this is the constructor which is called whenever you make an object of the class right here, right? So I can say pass here. Now this pass is inside the body of the constructor now, right? Okay. So now as I said that each and every argument takes this, each and every function and every single constructor and function, or we can say method inside the class needs to have this self inside parenthesis, which means this class, right? All right then. So now we know that we have just defined a class, we defined a constructor. Now as I said, we can pass value to the constructor. For example, if I say print, I want to print hello, that's it. Now if I call, now you can say I did not call. By default this was called. The moment I made an instance of the class, it is because that at the time of instantiation, automatically a zero parameter constructor is called, right? So this was called automatically. Now what if it accepts a parameter name, right? Now I'll have to pass this name. If it accepts, I have to pass, right? It's as simple as anything. So now if I run it, you'll say it's accepting one argument name. So you're missing one required positional argument name. Yeah, we have to pass it. So I will pass it. You can, if you want to pass it from input, pass it from anywhere. So I'll pass it here. I will say FAHIM, and I can concatenate. Here I'll say hello and I'll say name. Now you can see, without even making or without even calling any third-party function, you can still be able to do something like this, right? And it is very good at times, right? And yeah, second thing that we can try and do, let's say for example, if I have if I have a class, all right, so I can do many different things. For example, if I have a class computer right here, so it takes self, I don't take any. So I define some member variables now. It doesn't take any parameters, so I don't have to pass any parameter to the class. But yeah, we can define some member variables. I can say self dot name, and if you want, you can initialize it with values also. I can say self dot age is equivalent to right, and an ID has been here for 32 years, or we can say like that. Okay, fine. So now we have defined the name and age. These are member variables which are defined as soon as you create an instance of the class, because once you create an instance of the class, what is the first thing to be called? A zero argument constructor, right? So zero argument constructor is called, and you have initialized two variables, two member variables. One is name with NIIT, and second is age with 32. Now if I just go ahead and check, yeah, no error. Now after making an object of the computer, I can say, hey, I want to print C1 dot. Now you can say you get access to name, right, and you can format it like this. I can say format the age of C1 dot name is, and then we can say C1 dot age, right? So C1 dot name, C1 dot age. Now you can see the age of NIIT is 32 years, right? So now you can see the age of NIIT is 32 years, right? Doesn't mean that you cannot redefine it. Now this is the basic funda behind object-oriented approach, and this is why we love object-oriented programming, that you can yet go and make another object and override what is already been there. So now what we are doing here, we're just doing our own work, right? And now here overriding here, we can say C1 dot name is equal to, for example, I can add now NIIT Srinagar, and now I can say C1 dot age is equal to, let's say about, I'll say 29 years. So I can do this as well, or 25 years. So I can do this as well, right? So now you can see creating an object will allocate a new memory for you, right? And you are using that object and you are printing it, and then creating a new object which is now going to be C2 instead of C1, sorry. So now this is a new object, C2 is allocating a new memory, and you are basically referring to a new memory here and using that. So now let's see, the age of NIIT is 32 years, the age of NIIT is 32 years. So I have to mention C2 dot name and C2 dot age. Now let us see, the age of NIIT Srinagar is 25 years. Now if you want to see if I make two objects, do I get the same memory location or I get a different memory location? So that we can do like, let me comment it out and let me do this. So I can say print type of C1, right? And I can say print type of C2. And then we can get the ID of both, right? If we want, we can still get the ID of both, right? To check the memory locations. Do I have the same, similar, or do I have different, right? So first check the type. So type is class, right? So now we can, instead of type, check ID. Now we can see that both are having different memory allocations. Now this has a different allocation, which is C1 is having a different memory allocation and C2 having a different memory allocation. So which means that the more objects we create, the more memory is occupied for us, right? So that means this object creation means allocating space in the memory for the entire class so that we can do R&D, right? So this is what we can do. But yeah, we have seen practically that despite of the class having same data, we are still going to get a new instance. Why do we get a new instance? We have already checked. It's important in object-oriented programming that every time we get a new instance, we do new things. Now you can see clearly you're doing the age of an ID is 32 years. Here what you're doing, the age of C1.name and C, and here you're overriding it, and then you're saying, oh, I am creating another object now. Alright, now I'm going to pass something different here. I can pass it here also. You can see C1.name is equal to, let's say, what, NIIT JMMU Jammu. I can get it. The age of an IT Jammu is 32 years. The age of an IT Srinagar is 25. So you are getting it completely alright. Alright, so yeah. Now remember three things right here. Now size of an object. So I'll just document important things here. You're already noted. If you have not noted them down, then I'm most probably wasting my time writing these, right? So please note them down. So size of an object. Now, what does size of an object depend upon? So it depends on the number of variables and size of each variable. So now the size of an object, right? So we have seen that both objects have allocated memory, but what is the size of the object, or what is the size of both the objects? The size of the object completely depends on the class, right? So how many variables does the class have, right? It depends on how many variables are associated with the class, or how many variables are associated with the object. So it depends on the number of variables and size of each variable. Now who allocates? This is a very important question. So I'll just write it down here, Q. Okay, is it Q? No, it's by no means it's Q. Why do I write something like this? Alright, and answer is going to be this. And second Q is going to be who allocates, right? I'll say who or allocates size to objects. Answer, it is the constructor of the class, right, which allocates size to the objects, right? So now even if I don't have it, it's going to be there. A zero parameter constructor is always going to be there. That's what the call is going to be to. That's what the call is going to. That's what you are making call to, a zero parameter. If you don't make it explicitly, if you don't make it, so it is going to be placed by Python implicitly, automatically here, right? So it doesn't matter if you're mentioning it or not. Yeah, why do we mention them? Why do we mention and when do we mention? Whenever we need to pass some values, for example, I need to pass some values here in the constructor. It may be a database initialization code, it may be something, but whenever we want to pass, then we have to basically define it. Or in case of defining member variables, like we are defining it right now. So in that case, yeah, it is very important to define your constructor. Doesn't matter if it accepts parameters or it does not accept any parameters, right? So now remember these questions. So the size of an object depends on the number of variables and size of each variable, right? Here the variable is 4 bytes and here it's going to be more. And maybe if I make NIIT is a good training INS institution, so here the size of name is going to be much bigger because the sent string is bigger, right? So on and so forth. So you understand this? So it's not okay. Now can we change the values? Yes, we can change the values outside, as we have already seen, right, that we can anytime change. So now let me have two different things here. Okay, let me go ahead and make a class computer, and instead I will make one more function here. So I'll make another method here. I call this as, let me call this as update, and I'll pass self here. So this function is going to update. So I'll say self.age will be updated to 32, or we can say it can just take parameter as well. If you want to take parameter, you can take. So now let me say, now we are getting the age of NIT Jammu, also we'll say NIT Srinagar, N-A-G-A. So now I can print it. The age of NIT Srinagar is 32 years. Now we have this update function. I'll say no, you wait, I need to check for updates. I'll say c1 dot update. So this update is going to do its duty, right? This update will do the job. Now you can see the age of NIT is 32 years. Now I'll say update it to 30, or maybe it is 20 years here. So let me not update it first. Let me show you. Okay, now we are getting the age of NIT is 20 years. Why? Because you're creating an instance of computer and then say c1.name is equal to NIT Srinagar. You're just redefining it, right? So let's say if we are not redefining it, even if we are not redefining it, I'll say Srinagar. Now I'll say the age of NIT Srinagar is 20 years. Now I have to update the age. I call this update function. I'll say c1 dot update. So now this is the magic of object-oriented program. I call the update function and say the age of NIT is 30 years now. Why? Because I have updated. Now what if I want to update it with, let's say, about some number that you have to pass, right? So I'll say, so I'll pass some number right here. Okay, now you can see missing one required argument. So now update function accepts one argument. I have to pass, I'll say 32. Now the age of NIT is 32 years. If I don't call update and then if I print it directly, the age of NIT is 20 years. As simple as anything. And learning is going to be fun now because we are going to strengthen, and we are going to go a bit lengthier. The number of lines of source code are going to increase slowly and steadily, right? And you've understood the basic use of methods, right? That's what we call methods. Hey, I need to log in to Facebook. No, go and check whether the user is authentic. Call the authentic method. So it's going to be that simple, right? Alright, so let me try and make a complete authentic method for you. But before I make, so let me just say compare. So I will just create another thing for you here. So instead of update, let me say I want to create a compare method right here. So this takes 2 parameter. And here what we are doing, we are comparing the age. I will say if self.age is equivalent to other.age, right? So we haven't passed any other.age yet, but yeah, we can just do this. So I can say return true, else return false, right? What are we doing here? We are having 2 functions. Init will be automatically called when you make an instance of the computer. So you don't have to do that. So it's automatically initialized. But yeah, once you call compare, you're comparing self.age, which is 20 at this time, with other.age. That means you have not passed other.age, and other is not even here mentioned. So what if we don't have it? So other is not mentioned. So this other is basically going to be a parameter that we have to pass whenever we call this function. right, which is compare, right? So now this is an instance. I'm making an instance of my computer class. I made an instance of my computer class, and then I can say now after making an instance of the class, I can use it here. Let's say about C1, I can say print. So let me get rid of this. So I can say C1 dot compare. So now compare takes one argument, right? And now what argument do I give here, right? So now that is the question, right? If I say, okay, I give argument 20, so we are going to get same. They are both same, right? I'll say is equivalent to because this is comparison right here, all right? Alright, so now we are doing if self dot age is equivalent to other dot age. Now where is other dot age? We don't have other dot age here. That means we have to now pass another object here. So what will I do? I will say C2 is equivalent to, so I'm making another object right here, which is C2 is equivalent to computer. So now what is this? This is another object, right, of or another instance of computer class, right? So now I say C1 dot age. Now you see this C1 dot age is equivalent to 30, right? And now I say, once I have given C1 dot age 30 here, right? And then I say C1 dot compare, and I pass the complete object C2. Now let us see what we get. We are getting false, right? So because you're passing the complete object, now C2 already has dot age right here, and other is basically going to be this. That means other means C2. C2 means class dot age. Alright, so now if I say age is equivalent to 20, so if I pass, we are getting true right here, right? So we're getting true here. How is it going to happen, or how is it happening? Simple as anything. You're passing C2 as an object, right? So what is object? So let me tell you object, for example. Now when I pass object, so let me make this class. I'll say class user, right? And I will make a constructor, right? So I'll make a constructor. I cannot making a constructor would be too harsh, so I'll say I'll define a constructor right here, which is my 0 parameter. So I'll say self dot name, right, is equivalent to blank, so I'm not supplying anything. So I'll say self dot username. I'm not supplying anything, it's blank. I'll say self dot password, right? I'm not supplying anything, it is blank, right? And I will say self dot contact, not supplying anything, blank. I will say self dot email, not supplying anything, it's going to be blank. Now I will just close down the class, right? So I can say I will define a function here. So I call this as define update. So I am going to update this class right here. So this is going to be my update function. Okay, sorry, I'm just trying something very extraordinary right here. So now this update function is going to update all, because they have name has nothing, username has nothing, password has nothing, right? So I have just declared them. So now what I'll do here, I'll initialize them with some value, right? So you have to ultimately initialize them with some value. So I will say now let's say I want name is equivalent to, so I will give my name, right, and I will say not name, self. So now wherever you require to use the self, you have to mention the self right here. So right, it has to be within the parenthesis. So I'll say now self dot username is equivalent to something, right? Okay, let's see, FHIMKHEN. So I'll say self dot password is equivalent to PASSWORD So I'll say self dot contact is equal to 9086441234. So this is my name, username, password, and contact number. Okay, all done. So let's quickly go and make an instance of the class. So I can clearly say, right, u is equal to user. So now I'm making an instance of the class, and now I can say print u dot, for example, name. I require this u dot name, so I'll get nothing. print print. All right, so I'm getting nothing, right? Why? Because it has nothing. Name is just blank. Now I can say I want to update them all. I can say u dot update, please update, and then print. Now once the updation takes place, then I get Fahim. Or what you can do, constructor is automatically called when you make an instance. You can say, hey constructor, after declaring them, update them all. And now you can see automatically the updation is going to take place automatically, but you're not going to get anything right here because you have to basically mention it, right? So the better way is basically to use it outside here. So that's what we are doing here. But yeah, that's not an issue. What I want to tell you, for example, now we have this class right here. Can I pass the complete object to the class, right? So now what does this u have? U already has all the things. It has contact, it has email, it has name, it has password, it has update, username, and it has all the necessary things. So for example, if I have to pass this to another class, instead of passing name, username, password, email one by one, it will be better for me to pass the object completely, right? So because the object of users, which is this u, is basically an object of class users, so u has everything now, right? So for example, if I have this, okay, let me declare this function just to make you understand. If I have this display function right here, right, and this function takes one argument, and that is going to be user, which is going to be type user u. So this is going to be, or this function is going to take one argument, which is going to be of type user. So that's absolutely no problem. I will say now print user dot, now I will say print user dot name. Now where is this going to get user dot name from? So I will say, hey update, have you done updation? I'll say yeah, updation is done. Then you say wait, call display and pass the complete object, right? So you call the display function and pass the complete object, which is user u. So it's that's what is accepting here, right? It's accepting some user, right? So it's accepting something right here. So that's what we were doing previously also. But yeah, since it does not have any class, we are not passing an object of the class, right? So we're calling this function and we're passing the object of this class, which is this u right here. So this is exactly what we are passing here. Then you can say u is here, right? So you can just say u dot name. What is wrong with this? All right, so let me say class 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 test has a method known as display. So I will say test t, or we can say t is equal to test, and then I say t dot display, all right? So then I pass this u right here. So name test is not defined. Yeah, you are declaring it first and defining it afterwards, so that is the problem. Right, so now I'll say self. Right, so now you're getting frame. Now what is my intention? My intention is just to show you that you can, instead of passing one by one, name, username, password, contact, you can pass to the second class. Now we have second class test. It has a function display, and I passed u. What is this u? This u I have passed to the display function here, and it is an instance of user. But after I call and make an instance of user, then I update the user, and then I pass the same object of user class right here. So now this u goes to t.display, which is this test.display, and u goes here. Then I say I need to print u.name, and I can clearly see you're printing u.name as Fahim, and you can say I want to print user name, and then you can print. So this is possible. Passing the complete object is also possible. Passing any single parameter is also possible. Now what is the difference between passing an object and passing a parameter? Now this u object has name, username, password, contact. Otherwise, if it is not done like this, then you have to accept parameters like username, password, right, name, email. Then you have to accept these parameters manually, right? And then you don't have to do u dot. You can say, okay, I will print out username. Please give me username. Here I'll say u dot username. This way it's going to work. Now you're printing, right? So when I say u dot username, it goes to this username, and then password, then email, right? I have to pass them all. You can say u dot second is u dot password, third is u dot email, right? Or u dot, it's not email, it's u dot name, and then we have u dot email, right? So now you can say I'm getting Fahim Khan. Now why accepting one by one parameters like this when you can accept the complete object? That's what I wanted to say. I will say I'm accepting the object user, and I will print user dot username. And now you say, okay, I will pass. If you are accepting a parameter, or if you are accepting an argument, the argument that you are accepting at this moment in time is of type user. User is a self-defined class, you can see. So now you will say, if you are accepting user, I am passing you user, and then I say I pass you user right here, t.display, and I pass you the complete object, which is this u. U is an object of user, right? And here it passes, and then I fetch out. This is a single object user has everything, rather than passing everything one by one. I hope you have understood it. It's not like rocket science. It's very simple. Yeah, but initially, once we are learning object-oriented methodology, we're not going to understand everything at the first go. It is going to take 3, 4, 5 classes, right? So all I want you to have focus and be patient. You are going to get it one by one by one. So now the question for today is, what are these variables known as? Whatever you are defining here in the constructor, right, these variables are defined. So let me get rid of all this here. So I'll just keep it u equals user. So this is an instance. So what is this? This is making an, I'll just define it here, or I will define it like that, making an instance of the class, or make an object of the class. You already know, right? So once you make the instance of the class, what is happening here? Hey, please tell me, what is happening when you make an instance of the class? Look at the class users as there are some member variables. There are some member variables being declared. Now what do you want to do if there are some member variables being declared? Those member variables are called as instance. So these member variables are known as actually instance variables. Now why are they known as instance variable? As I said, that whenever you make an instance of the class, the constructor is automatically called. That means the variables which are initialized on the instance are known as instance variables, right? If they are inside methods, so they are not instance variables, right? Let's say if they are inside some method, so they may not be instance variable. What is time? Okay, Yeah, we have good amount of time remaining, so let's get going. So these are known as instance variable, and I give you the reason why are they known as instance variable, because they are instant, or we can say they are instantiated, or they are initialized at the time of instance creation, right? So I hope you have understood this. Now, for example, if I go and create a variable here, for example, if it does not exist, right, I can say u dot something, and this is available only with Python, right? It's not available any other thing, is equivalent to I do not know, right? So now, is something existing? No. Does it exist? Does something exist? No, something does not exist. If you see an object of user dot something, so it could be u dot name, right? Or it should be rather u dot name, u dot username, u dot password, u dot contact, and u dot email. There's nothing like u dot something. But yeah, if I do write this, if I say print u dot something, right? So here I get I do not know. But this is also possible in Python, and Python is the only language wherein this kind of variable initialization and declaration is possible. It's not possible in any other language, because you are making an instance variable outside the class. Now you're making u dot something. It's not declared here. You're making it outside now, right? So declaring it right now, and then you're passing it to, or you're printing. You can even pass it to some other function or any other class. So that is also possible, right? All right. And we can even change instance variables. If they are instance variable, we can change name, we can change them here as well. For example, we can say u dot name is equivalent to, right, it has empty here, so it has something here, so I can say now it has, let's say about Fahim here. So that is also possible, right? So that we can do also. Right, so now that you have understood what instance variables are, so let me tell you most important thing of Python, which is class variables. Now, what are class variables? So I can say, right, for example, it is class. I will say connection is equivalent to on. Now, this is connection. Now, how do you access this? This is called as a, right, so I'll say it is a class variable. So now this is a class variable, right? Now how is this a class variable? Because it is in the class namespace. It's not outside the class namespace. These are instance variables because they are initialized whenever you make an instance of the class user. So now they are class variables because they are within the class namespace right here, right? Why are they instance? Because they are in the instance namespace, right? So it depends on the namespace wherever you are. For example, if I go to okay, let me go to MS Paint right here, and this is initialization. So this is the namespace here, and this is the class namespace, right? So this is the class namespace here, and this is what we call as instance namespace right here, right? So that's why we call these as class variables and we call these as instance variables, right? I suppose you have understood this, right? And now how do you access, or how do you access them, right? You can access them similarly. I can say u dot, now you are getting connection as well, right? So this is class variable. You can say u dot connection has to be printed. So we'll say, hey, I need to print u dot connection, and then you can easily print. So we can say u dot connection. Now then we have an error. So connection is equivalent to on. We are getting some kind of file error here. So let me call this as con is equivalent to on. Then I can say I need to print u dot con Still getting some unexpected indent. Maybe because of this we are getting it. Who knows? So let me indent it properly. Yeah, so it was bad indentation. So con is on, right? So now you can see, right? We can even say connection. So we can even type connection. We had some problem with indentation. That's why we used to get that error. Right, so we are getting on right here. So this is how you access. Now there is different usage. I'll come to or I'll define and describe them later on, right? Or you'll be able to know them in 2 or 3 classes, right? You'll be able to know the difference between class variables, instance variable, maybe 2 or 3 classes. And now we still have static variables, right? On now what I do right here. So let me. Static or class variables are also what we call them as, right? So you can either call them static variables or you can call them as class variables. So both are going to work, so that's not an issue. Right, so we have both, so you can have both working right here. All right, and that's it. So we are going to start with accessors and mutators. So we still have some good amount of time. So I'll tell you how accessors and mutators do work. And the second thing that I want to tell you that we can still define a class like this. So let me get rid of all. So I'll say class user. So we'll make 2 classes, number 1, and we'll make another class. Let's call this as authentic, auth. So we can make these 2 classes and we can make sure that we basically have different functions and methods right here. So this auth, or we can say, we can make this class accounts, and the accounts class will have functions like it is going to have is valid, like we have already learned. And here we are going to accept one object, which is a user, right? It is going to have, so let me have pass here by the time. So let me pass it here. Second function is going to have, second function that we are going to have is authentic. So this is user, right? So I'll say pass here. Third function that we are going to have is authorize, and let me pass the object to user here, right? And fourth function that I am going to have is define is valid, is authentic, authorize, and we are going to have login function, and this is also going to accept user. I will say pass right here. So this accounts class, right, is going to be saved in a different class. So I'll create a new class and I will save this accounts here in a different class, right? I hope you understood this, right? Okay, right. So now this class will also have defined init. So I'll just show you how to develop a complete object-oriented based login system. So I'll say self here. Also, it needs to have self. It needs to have self. Right, it needs to have self, and this also self. So now I'll tell you how to deal with this. So this is going to be my accounts class, and second, so I'll just save this as accounts, and here the second class, so I'll save this as users, right? I'm saving this as accounts. Now we have 2 classes. Users will act as a model, and then we have accounts. So this is where I will go, or this is what I will use for login authentication and authorization, and this is what I will use for give and take of data. And this is going to be my oops, wherein I will take input from the user and do rest of the things, right? So now both the things are ready. Now this accounts will also have define init, which is going to have a constructor that is self 0 parameter. So let me pass it by the time. So now we have to first understand accessors and mutators. So now we'll understand accessors and mutators in a practical way today. so that we practically develop it and understand what is accessor and what is mutator. We call them as getters and setters as well. So right, okay. So let me carry on with this users class, and let me say that it is going to accept this right here. All right. So now this is going to be my constructor. All right. So this constructor is going to accept, for example, we have username and password, right? So let's say we have username and password. So I'll say self dot username is equivalent to, so let's say USR username and PWD is password. Any two parameters, you can set any two parameters. So self.username is just declaring, you're declaring an instance variable, and not only declaring but initializing with USR. And then you're declaring self.password, you're declaring another variable, not only declaring but initializing another variable, and it is going to take this PWD. So now what we have been able to do so far, we have been able to make this constructor, right, and with two instance variables, right, being initialized by whatever you pass to the constructor at the time of initialization. It depends if you want to pass. If you don't want to pass, don't pass. So let's understand accessors and mutators by this way. So let's not pass anything, right? So let's just keep it as simple as anything. So now we have username and we have password right here. Now what I want to do, I want to give it read and write permissions, right? Read and write permission, that means I'll create a method that is only going to access, and second method that I'll create is only going to write to this, right? So that's called as getters and setters, right? So let me quickly create a getter. So let me quickly go and check time, which still have timings. All right, so let me create a getter. So I will say define. So I'm defining a function, right, which is going to be my define a function which is going to be get username. So this function, whenever I call get username, whatever is in this username should be returned. So I'll say return, right? So this is going to accept this self here. So now I'll say accept self dot username. So when I call get username, whatever is in this username, I'll get. Why? Because you're returning whatever is in this username variable, you're returning back to this function. So that's called as, it's called as an accessor. Now let's define a mutator for this. So I will say set username. So mutator is going to update the data right here. It's going to set the data. So let me accept self here, and I will say now I will not only accept self, I will accept one parameter which is going to be user USR and so I'm going to accept here one argument. I'll say this dot user. So what is this? Sorry, this and self means one and the same thing, but this is in Java and some other programming language. So right is equivalent to username. So this is done. Now accessors and mutators are done. So this is accessor, right? Whatever is in this username is returned back to this get username. So when I call get username, I'll get whatever is in this instance variable username. But in case if there's nothing in this, I want to upload or I want to update it, right? I want to update the username instance variable. I want to fill it with some data. So that's what I do. I'll say I call this function set user name, and I pass one parameter right here, and that parameter is going to, this is initialization. What is happening? You're transferring whatever is in this parameter is going to be assigned to self dot username in here. So you're assigning whatever is in here, you're assigning it to self dot username. So this is called accessors and mutators. All right, and let me show you one example of this accessors and mutators. So I will say u is equivalent to user. So I'm making an instance of users. I can say u dot set. Now I'm calling u dot set username. I'll say FAHIM. Now you can say print, right, u dot get user name, which is again a function. So it's again a function. So now you can see you're getting Fahim right here. Now set username accepts one parameter, right? And whatever you pass to that parameter, well, right, you're setting this username right here. And second, what you are doing, you are using get username. So get username, right, you're returning whatever is in this username will be returned back to this function. That means this function has whatever it has, whatever is in this instance variable username, and this is the updation. So this is also called as, this is called as setter, or these are also known as setters, right? And these are also known as getters, right? And the second name and the most beautiful or the most decorous name given to them are accessor methods, right? So this is also called as an accessor method, and this is also known as mutator method. So mutator is used to update and accessor is used to access. So these are also known as accessors and mutators in Python, right? Or we can say getters and setters in programming language. So I know that you're not completely getting it. I'll just start tomorrow's lecture with getters and setters straightforward, and then we'll move to this accounts and whatever I have done. Made accounts class, made users class, and wherein I'm explaining you what accessors and mutators are. And here we haven't done anything special. We just declared is valid, authentic, authorized, and login functions. So here we are going to apply encapsulation, and I'll tell you the basic rules of now object oriented, which is polymorphism is there, abstraction is there, inheritance is there, and many different things which are already there. So we'll be learning them in the concurrent classes, right? And also learn the implementation of those. Wish you good luck till then. Do pray for me and practice this. See you tomorrow. Bye bye. Take care.